Okay, um, if everybody's got settled, then we can start with our next talk, and we're going to curl lots of things. And Daniel is going to show us how.
No, it's on.
Yeah, there's a mute button.
No, it's on. Isn't it?
No, it's off.
Can you hear? Is it off?
Yeah, you have to put it higher.
I have to put it higher or speak louder or both. Hello? Yeah. Let's make it like this way. Hi. You can say hello to each other up there. This is what I'm going to talk about today. All right, I'm going to start my timer too. So, I'm going to talk about curl. Curl, Internet, all the things, like as a client side. Curl is everywhere today. I'm going to talk about how we got here, who's using it, a little bit of a very quick crash course how we use curl, and something about the future, I think. I work for Mozilla these days. I'm a network hacker. I've been working with curl since forever. I do Firefox stuff these days, and I do other sorts of networking things. I also participate a bit in the ITF and whatever. So please interrupt me and ask if you have any questions. If you have any questions about the mic. I try to do, this is a bit of a quick rundown about curl, but I'm sure there are some things I will leave out, so feel free to ask during the talk or after the talk or whenever. So, curl. Back in the day, there actually was no curl. There was nothing, actually. Well, there is another command line tool known to some that I would mention, that you all know, that you'll. But actually, it didn't exist in my mind. I didn't know about it. And then, one of these days, back in 1996, and this is actually the year they made this movie. I think it's kind of fun. I got this itch, I want to do something. I wanted to download HTTP. I want to do some currency rates translations actually for an IC bot I was writing. So I better make a little tool that can actually download HTTP. So then I added a couple more protocols, like FTP. You have to have FTP. Gopher, that's where the edge is. So let's implement that too. And since I added a couple more protocols, the former names were not really good since they were called HTTP GET. And it wasn't really suitable anymore since it could actually upload and there were more protocols. So I named it curl and we called it Everything Was Fine and Dandy in 1998. So then today it's slightly more. We have basically every single internet protocol you can think of and a bunch of other things. You can upload, download, everything, of course, client-side still. You're writing internet-based client things with curl. And it's nowadays a library then. It wasn't that originally, but that's kind of what drives the usage today. I don't intend you to actually read or care about all this, but basically we do internet protocols, sending stuff up, getting stuff down, or at the same time, all protocols, one protocol, whatever. A lot of data, back and forth. Roughly, perhaps, 1 billion users or so. I don't know. Who knows? I mean, counting all the users, how do you count users when you're an open source project? There's a bunch of users of curl, like perhaps these, or at least these are names of companies that I know use curl because they told me, or someone found out that they were using it. Basically, a lot of known companies and a lot of unknown companies and a lot of commercial products and a lot of open source projects and a lot of devices and a lot of whatever. Actually, you all know this. You write this open source project. It is open source. You have the license. Anyone can use it. And everyone uses it. Or doesn't. You don't know. And I don't know. And people don't tell me when they use that curl. So all of a sudden, I figure out that, oh, they're using it in a car somewhere. Do you use curl? Oh, fun. I'll take down your, I can add you in the middle. No, but so this, I have this list of companies using curl in commercial surroundings because I think it's like this. It makes it fancy, and I can kind of show the others that, ooh, all these ones use curl. So the other day, actually, a couple of months ago, the list had 100 companies. And I thought, oh yeah, that's 100 companies using your product. That's kind of cool, right? But is it really 100 companies? It might be 2 more, right? 3 more. So I started Googling, and this is the list I found. I actually doubled the list after 1 day of Googling. So now it looks like this, and I bet it's not kind of the end of it. A lot of users. And what do they use curl for? I mean, what are all these companies doing apart from being, I mean, they actually cover pretty much everything in the world, right? I mean, these companies, they make devices, they make software, they make whatever. And they all use curl in what? Like, yeah, Mac OS X. Yeah, that's what is that? 100 million users or so. They use it by default, so they use a lot of applications that use libcurl, and they use curl the command line. And every single TV these days, you know, they add all sorts of fancy internet stuff. So high-end TVs, everything these days. All the major brands use curl. iPhones and iPads ship curl inside, even if they don't expose the API. And all phones, Linux, games, version control systems are also using a lot of curls. Cars, very big into infotainment. So pretty much every modern high-end car infotainment thing. PHP sites is very big into PHP since it's been kind of the default way to do HTTP and URL things in PHP since the beginning, or since the beginning of curl at least 15 years or so. So pretty much all the big PHP sites use it. Set-top boxes very big into TV things in general. So audio equipment these days, audio receivers high-end, they do download a lot of stuff. Blu-ray players, they apparently also download a lot of stuff. Printers, Fox Crash Reporter, which makes it fun because it makes me delivered in all the Firefox releases. Oh, yeah. And basically, whatever. I would even say that there's not a single person in here who's not using curl actually. Probably most people are using curl, at least in one device, probably many more devices. But why would they use curl? And I would say that there are a number of reasons. Possibly, and what anyone recognizes, as soon as you start to, I mean, how hard is it really to implement anything that speaks HTTP? I get that question a lot, actually, since people are writing their own whatever to speak, especially HTTP, because HTTP is very simple. You send a little text and you get a response back. Why do you need a big, honking, complex library to do that? Or you do another whatever protocol. Why do you need something big when you can do it very small? And that's you're easily misled into believing that the first time you do this. And then after a couple of years, you figure out that all those protocols are really complicated. And of course, the internet is not really abiding to these protocols. They're abiding to whatever people decided to do over the years. So you have to adjust and polish corners everywhere. So of course, curl being open source is of course one of the key systems. I mean, the key answers to why people are using it. Of course, without it being open source, nobody would care. And it's also, I would say, and of course people will contradict me here, but I would say also that the key to why curl is popular is because it's extremely liberal. It's MIT licensed, which basically is a simple BSD version, which means that you can do almost whatever you want to do with the code. There's absolutely no obligations to get back to us with any patches or changes. You do whatever you want. You ship your products, you patch it, you change it. Go ahead, fine. But it's not a problem. They won't do that. Also, in curl, we have a very simple, and I'll show you soon. It's very simple, and foremost of all, it's a very stable API. it is the same API. We don't change the API. It is the same. We have the same since 2006, I believe. We last changed it, and we stick to it. So your old stuff works with the new stuff. And it's still powerful enough. You can do pretty much what you want. We were pretty early on out there. So we provided a library. Back in the days, you all remember libwww, right? Awesome library. It was basically the first HTTP library. It's super complicated, but it was really powerful. It's actually still pretty powerful, but I guess nobody's using it. And I would say, I mean, we're here in the embedded room, so we all know that C is still the portable language. It's still where we're going. I mean, if you want to be portable, if you want to be everywhere, you don't go doing fancy stuff in fancy languages. You go down to the bottom. You do it in C. C libraries is still everywhere. That means that we're not only talking Linux. We can actually build and run on all sorts of RTOSes and BSDs and whatever. And I mean, yeah, there is some effort to make sure that we actually build and run and work on all these systems, but it's still, there is no other internet transport library even close to the portability that libcurl is. And of course, we have bindings for every language. I can say this with a fair amount of certainty. I'll show you the list soon. It's actually more languages that I know ever existed. And we have decent documentation, of course, and decent stability, of course, with some kind of, how do you define that? We support all the protocols, basically everything you want to do over the internet as a kind of internet transport protocols. So if you want to transport stuff from a client, curl has it all. It's fairly fast too, basically because it's still C and not higher languages things. It also allows, you can build your own thing to disable a lot of stuff, which of course makes it not exactly API compatible, but you can at least shrink the footprint to something pretty small and pretty specific for your needs. I don't know of any other projects that support as many TLS backends, and that's kind of a hobby of mine. We support 11 different TLS libraries. I don't think anyone here can even name 11 different TLS libraries. That's a challenge for me too, but there are many TLS libraries, and we support 11 of them. Yeah, and that's fun. That is also kind of helpful, especially for embedded projects, since embedded projects tend to do specific purpose things, and when you do specific purpose things, you know when you can remove some features and gain some footprints, or gain performance by removing some other things. And a lot of these different TLS backends allow you to tweak it quite a lot. And small devices still like C. Yeah, that's pretty much the same as I already said. So we have a curl project. We do curl and libcurl. Curl is the command line tool, libcurl is the library. Small and tiny things. We transfer data, internet application data, back and forth. That's what we do. We provide these. They're stable. It's the same thing. We don't really do anything new. We do the same thing as we've been doing for forever. We have a stable API. We work on pretty much everything that is 32-bit and has a decent POSIX API, even Windows, if we should call that decent. And it's MIT licensed, of course, I mentioned. So I wanted to also just say that, yeah, I say we have 1 billion users. I don't know. Maybe there are 1 billion users. But in the project, it's not kind of, you can still reach 1 billion users without being that big. We have 1,200 contributors if we count all the users that we ever got help from. I try to keep track closely to give credit where credit is due. So we make an effort in the project to keep track of everyone and say thanks, because that's the way we work. And so we have 30 to 40 new contributors per release. We do releases every 8 weeks, every second month, basically, on the clock, always, everywhere. I mean, all the time, never ending. And the number of contributors then kind of increasing linearly, because a lot of our contributors are one-time drive-by patchers. Here's a fix, and we never see them again. a really small project, core team-wise. About the entire core team is here in the room today. You won't find them because they're hidden among you. But we're really small. I say less than 10, but we're probably more like 5. It's tiny, tiny project in that aspect. But we're having fun. And I wanted to mention that we're all volunteers. I said, and I mentioned, I'm employed by Mozilla, but that's a recent thing. I've been doing this since basically my childhood, and we all are here voluntarily. We all spend spare time on this. We don't get paid to do this. There's no big company backing. There's no company influencing us or driving us in a particular direction. We run in all directions wherever we want as individuals, and we're having fun while doing it. And I wanted to mention that also, okay, every language. This is not every language, but I didn't know about all these languages. And we have bindings for all of these, or rather there are bindings for all these languages. If you want to access libcurl using something else than C, and a lot of people seem to prefer that. And of course, when I say bindings, I mean there are projects that are writing bindings and providing bindings to do libcurl transfers from these languages. Some of them are not really good. Some of them are really good. It'll vary. If you're missing your particular language of choice, you have an excellent opportunity to dive in. So, how do you use curl or libcurl? I do like this picture. It's a bit dark, but this is how we look when we use curl. So, how I wanted to just show you a little quickie how we actually use libcurl from kind of API-wise. Basically, since we're talking about we're in the embedded room, embedded use, you often end up building libcurl yourself first because you have your particular need. If you're using it on the desktop, you probably just apt-get or yum install or whatever. But when you're doing it on embedded, you'll probably build it yourself. It's very easy, just configure, make, install. Well, mostly. And then you can, I mean, as any decently old open source, you have a bazillion different configure options. So you can basically tailor it to do whatever you want and not do whatever you want and blah, blah, blah. But you build it. And you have a lot of these embedded systems, build environments like Buildroot and Yocto and OpenEmbedded and so on. They all have recipes for doing this. And they'll help you. Many of them will also help you to build it with your TLS library backend of choice. Right, all Linux distros have binary packages and so on, so that'd be easy. Installing it on a desktop is really easy. I mean, if you're running Linux. Most Linux systems will already have it installed, at least the kind of binary stuff. So, when using libcurl, it was more of a fluke originally, but kind of we're organized around transfers. We speak of transfers. You do transfer libcurl. You transfer data up or you transfer data down, or both. Some protocols actually support both in some aspects at least. Like you can do, with HTTP, you can actually post data and it'll receive data. So it'll be two directions, and while most other protocols will just do it in one way. It doesn't matter. You set up a transfer, you set a lot of options when you want to, how you want to do your transfer. You do that with this curl easy setup, set opt. You set your characteristics for the transfer, and you create one of these handles for each transfer you want to do. If you want to do them parallel, you do many. If you want to do them serially, you can just reuse the same handle. You set your options, how you want to do your transfer. For example, URL is one important characteristic for a transfer. That's the kind of course, it's a mandatory thing. You want to transfer a URL. You might want to receive your data in a callback or however. So there are like, you want to set some authentication. Perhaps you have some users' credentials, whatever. We have 200 options. You want to tweak whatever you want to do when you do a transfer. We support a lot of odd, weird things in the protocols. You set it, you ask for transfer, done. So for example then, if you want to do, you select, you have the API in libcurl. Do you want to do it blocking or non-blocking? Asynchronous or synchronous? We have two different interfaces really. You make your choice. If you want to use a lot of threads, you might use the blocking one. If you want to do it in a single thread, you might use the non-blocking one, or whatever. If you want to scale up to, if you want to do 100,000 simultaneous transfers, you want to do the non-blocking one. So here's how to do it. You create a little handle. You set some options. You have a URL. You tell it some, yeah, I want to follow redirects in HTTP. And you do the transfer. Bam, done. That's as easy. That's how you do a single simple transfer, asking for that URL. And of course, this is kind of a default settings for everything else. So you'll get this sent to standard out, which you may not do in your application. And when you're done there, you clean up the handle and you're done. Transfer oriented is kind of a single transfer. And in a typical program, if you want to do more of these transfers in a serial manner, you would just reuse the same handle again, set some new options, and do it all over. So, and to do this non-blocking, it's basically the same thing. You create an easy handle, which is a single transfer. You set some options. I want to do it on this URL. And then I create a multi-handle. This is going to hold many transfers. And I add my single transfer to the multi-handle. And I can do this any number of times, any number of simultaneous transfers. I've had users do it up to 50K parallel transfers. It usually gets messy when you end up close to the 16-bit boundary, but you can work around it. And of course, you need to expand the number of open files that you support and so on. And then you run all those transfers simultaneously in a fun little select loop or whatever. And then you're done with it. You remove the handle from the multi-handle and you close everything down. Fine. And you can also do it event-based. But if event-based then being called when something happens on one of those sockets, it avoids select and poll. You can do it without getting married to any kind of event-based library. You can do it with whatever you want to do. And it really scales if you want to do a really large amount of transfers. Get away. I'm out of time. If you want to do a really large amount of transfers, event-based is really the way to go. Like if you're beyond 100, 200, 300, 1,000 transfers, this is really the way to go. It really scales. And that's the libcurl function called to do that. It basically allows libcurl to tell you these are the sockets you should wait for. Tell me when something happens. And that's the way you use event-based libraries in general. So when the event-based like kevent or whatever, libevent or libeb2, whatever you use, you'll tell libcurl that there was some action on this socket and it'll go, it'll fly. It'll scale really nicely, really to a really large amount of transfers. But I would say that as you all know, if you've ever done anything event-based, you know that the logic around that becomes really messy. It's really hard to follow because you have to do a lot of weird state machines, getting called and callbacks all over. Yeah, I wanted to mention that we have we have documented this pretty good, I would say. Possibly too good at some points. It's really hard to find the docs sometimes because you drown in a hole. And I wanted to mention, that got messy, that we have this fancy --libcurl command for the command line tool. If you ever run a command line with curl, some people do, you can add this --libcurl code.c, and it'll generate the libcurl code for that corresponding command. So you'll have the code written for you. It's not exactly the way you want it. You want to tweak that code, but it's an awesome template. If you ever want to repeat a command line in a libcurl way, that's the way to do it. And usually, I mean, as I said before, there are a bazillion bindings, but most bindings are very close to the libcurl style API, the C API. So you can usually convert that even to PHP or Python or whatever you want to do. That's kind of a great way to kickstart it. I'll just show you that we have some ideas on how to do things in the future or what to do. here are some ideas. Of course, we are all just depending on volunteers, so we just do whatever we want to do next. Of course, you can all help out, and whatever you want to do, you're all welcome. And we did have a billboard in Silicon Valley, and that's fun, right? It doesn't make any sense at all, but it's fun. And that's it. Thank you. There are some URLs too, so we can. Any questions?
Yes, that options to generate the code corresponding to a command line.
Yeah.
Do you have another language? It's just enough to specify our extension or not?
No. But
Generate C.
yeah, it writes a C code, but the API is usually very similar to that. So it's usually you just need to know which options to use. So it's fairly often just a pretty straightforward conversion.